Okay, 11.4, geometric series. Students will be able to find sums of geometric series and find specific terms of geometric series. So geometric series, that's just the sum of a geometric sequence. So we're just going to add up all the terms of a geometric sequence and call it a series. So we have a formula here. First term times 1 minus our common ratio to the nth power over 1 minus r will give us the sum of the first, n terms. So let's take a look at example 1. In order to use this formula, we need to know three things: a sub 1, n, and r. So let's see what we know. As we look at this series, my first term is obviously 3. My n is the number of terms, 1, 2, 3, 4, 5, 6, so that's 6. And my r is the common ratio. Well, what's happening here? 3 times 2 is 6, times 2 is 12, times 2 is 4, and so on and so on and so on. So r is 2. Okay, now that we have all that, we're ready to just plug this stuff into our equation, because we just do our first term, which is 3, times 1, minus r, which is 2, do our nth, to an nth power, which n is 6 here, close out the parentheses, and then it's 1 minus our r value again, which is 2. Okay, so now let's just work this out. We would get 3, 1, minus 2 to the 6th power. Well, let's see. 2 to the 4th I know is 16. 2 to the 5th is 32. So 2 to the 6th must be 64. And 1 minus 2 is just negative 1. So that means this is 3 times negative 63 over negative 1. And 3 times negative 63 is going to be negative 189 over negative 1, which just turns into positive 189. There we go. And now we found the sum of those three numbers. And if we add those 6 numbers, if we add those 6 numbers together, we should end up with 189 as well. We could check our work. Now, obviously, we could have just added those 6, but we're going to get ones where, there's a lot more than 6 terms, and so we'll have to add those. For example, look at this next one. We don't even know what all the terms are, but they do tell us find the sum of the first 10 terms. So, again, identify your a sub 1, your n, and your r, plug it in the formula, and figure out what the sum is. I'm going to let you guys try this on your own, so you're going to pause the video. I'm going to put the answer up in just a second. Go ahead and give it a shot. Okay, well, we filled in these terms together, so then I just plugged it into the, we didn't fill these in together. So that was 4, because that's my first term, 10 is my n value, and 3 is what I'm multiplying every single time. Plugged it all into the equation and just simplified, and I got 118,096. All there is to it. Okay, so what happens if they give it to me in sigma notation? Not much different. Just remember that I'm starting with whatever they tell me n is. It so happens that my n is 1, so this is going to be easy. If I plug in a 1, 1 minus 1 is 0. 2 to the 0 is 1, and I'm left with just 5. So this should always just be my a sub 1, this first term here, with geometric explicit equations that are inside sigma notation. Sigma notation should always have the explicit equation. Okay, so how could we evaluate this then? Well, the same idea. Let's just identify our three things. What's our a sub 1, what's our r, and what's our n? We know that we're starting at 1 and going to 6, so our n is 6, our r is 2, and our a sub 1 is 5. So just plug it into the equation. 5 times 1 minus the r value, 2 to the 6th power, all over 1 minus the r value. So this is the same thing as 5. We already said that that 2 to the 6 is 64, so this is going to be negative 63, because 1 minus 64 is negative 63 over negative 1. And 5 times negative 63 is negative 315 divided by negative 1. That equals 315 total. Boom. Okay, all there is to it. So try this next one on your own. Pretty simple. We're even doing the same n values, and I'll put the answer up in just a second so you can check your work. Okay, so your a sub 1 is 2. Your n value is 6 because we're going from 1 to 6. If this said 2, my n value would be 1 less. So I do it by the top minus the bottom and then plus 1. 6 minus 1 is 5, add 1 is 6. So we could start at numbers other than 2. So for example, real quick, if I would have said like, hey, this is 10 and this is 4, my n value would be 10 minus 4, which is 6, plus 1. My n value for this would be 7. So anyway, just showing you that. Okay, so n is 6, my r value is right here, it's negative 3, plug it all in, work it out, and I got negative 364. Okay, let's move on. This one says, find the sum of geometric series for which a1 equals 15,625, an is negative 5, and r is negative 5, or negative 1/5. Okay, here's the situation here. What do we need to find the sum? Remember, we need these three things, a1, r, and n. We have a1, we have r, we do not have n, so we have to figure out n. The only equation that gives us n for a geometric series is the explicit geometric equation. So I'm going to do that over here. If you remember the explicit geometric equation, it was a sub n equals a sub 1 times r to the n minus 1 power. Okay, well, we could just plug this in. We know what a sub n is. We know that it's negative 5. We know that a sub 1 is 15625. We know that r is negative 1/5. And then up here is going to go n minus 1. Okay. We can reduce this just, or simplify this just a little bit by dividing both sides by 15,625. All right, I'm going to go up here because I'm out of room. When I divide negative 5 by 15,625, it reduces. It reduces to 1, and it gets to be negative 1 over 3,125. And then over here, we would just have negative 1/5 to some power of n minus 1. Okay, a couple of things right now. We can use logs to solve this, no problem. But we also might be able to just use some reasoning here. We have a negative number to some power, and it's going to kick out this negative number here. That means that this thing has to be odd. Whatever n minus 1 is odd. And that means that n is going to be even, right? Because an even minus 1 is always going to give you an odd. So we got a little bit of information just from looking at that. Also, we see that we have a 5 on the bottom, and we have some multiple of 5 here. Maybe we could figure out what this is by rewriting it in terms of 5. So I would go to my calculator and plug in 5 to the 3rd, 5 to the 4th, 5 to the 5th, 5 to the 6th. Figure out what this is. So I'm going to do that real quick. And when I messed around with it a little, I found out that 3125 is the same thing as 5 to the 5th. So we may not need logs to solve this. Because really, negative 1 to the 5th power is still going to be negative 1. So we could actually write this whole thing as negative 1/5 to the 5th power equals negative 1/5 to the n minus 1 power. And we can see really quickly, what does n have to be? Well, 5 equals n minus 1. We said this whole thing was going to be odd. So what does n have to be? It's got to be 6, right? 6 minus 1 is 5. Now we'd have the same exponents, and that's what would make them equal. So all that to find out that our n value is 6. I'm going to write that over here. We needed that. Okay, we did all that work. I'm going to erase it now because now we have to do what they actually want us to do. They want us to find the sum, right? So we're going to go through this and we're going to find the sum. Well, the formula for the sum again is S of n equals a sub 1 times 1 minus r to the nth power over 1 minus r. Now let's just plug in everything we know. We know the a sub 1 is 15625. One minus my r is negative 1/5. And that's to the power of 6, because that's my n value, all over 1 minus negative 1/5. A lot of simplifying to do here. Again, I'm going to kind of go up here. We got 15625 times 1 minus, and negative 1/5 to the 6th power. What is that? We go to our calculator. Well, it's 15625. And then this is 1 minus 1/5. Well, we could write this 1 here as 5/5. And this is going to turn into a double negative, it turns to a positive. So this is really like a 6/5 down here. Okay, let's keep going. If I was going to do 1 minus 1 over 15625, I can make the common denominators here, 15625 over 15625. Right, just make the same common denominators. And it would just be 15625 up here minus 1. Let me just write it out so you guys can see it. I'm just running out of room here. So out here we have 15625 times, I'm going to write this as 15625 over 15625 minus 1 over 15625 over 6/5. Well, hopefully you see what's going to happen here. We're just going to take away 1. And we're going to have 15625 on the outside times 15624 over 15625. And that, of course, is all over 6/5. Okay, well look, these guys just cancel out. And we have 15624 divided by 6/5. Well, anytime you have a number divided by a fraction, the same thing as multiplying with a reciprocal. So we're going to go off to the side here, run out of room. It's a long problem. Should have given us more room in this. It's just like 15624. 5, 6. And when you do that operation, it ends up being 13020, so 13,020. Now that was a lot of work. A lot of work to get to that answer. So, you may want to try that one again by yourself. Just do it all from the beginning and see if you can follow it. But there's a lot going on there. All right, this last one's a lot easier. So I'll just do this one with you and then we'll be done. It says, find the first term of a series for which S of 8 equals this, and R is 3. Okay, well again, just use our summation equation, which we know is yes. And now they're telling us it's the S of 8 equals A sub 1 over 1 minus, well, what's my R value? 3. What's my N value? They tell me right here it's 8 over 1 minus R. And they also told me my S of 8 value, didn't they? 39360. So this whole thing actually equals 39360. So let's simplify this out. 3 to the 8th power, that is 6561. So we have A sub 1 times 1 minus 6561 over negative 2 equals 39360. 1 minus 6561 is going to be negative 6560 all over negative 2 equals 39360. Okay, we can divide both sides, or I'm sorry, we could divide this negative 2 through there. And that would give us positive 3280 times A sub 1 equals 39360. And then the last step is just divide both sides by 3,280 and figure out what a sub 1 is then. And it is 12. So a sub 1 is 12. Told you that one's not as bad as the last one. Okay, that's it for 11.4. I'll see you guys in the next video.